Hello everyone, welcome to my channel Chemistry is Fun. Today I will continue with the topic imperfections in solids. So it is imperfections in solids part 2. This is for cbse class 12. So we have already seen that there will be sometimes imperfections in the arrangements in the solids, and in continuation today we will see the impurity defects. For example, see if we have molten NaCl. In that we have a little amount of SrCl2, strontium chloride. So if molten NaCl having little amount of strontium chloride is crystallized, we find that some of the sites of sodium ions are occupied by strontium ions. Okay. So how we represent sodium ions? Sodium ions are Na plus. So you see there is unit positive charge, single positive charge. Whereas strontium ions, it is Sr2 plus. So, since it is having two positive charges, each strontium ion can replace two sodium ions. The neutrality will be maintained that way. Charge balance will be there. But there will be one vacant site. Because see, one strontium ion is replacing two sodium ions. So it will occupy the site of one ion and the other site remains vacant. For example, initially there are two sodium ions, but when the strontium ion takes its position, it will occupy only one site, whereas the other one will remain vacant. It occupies the site of one ion and the other site remains vacant. These cationic vacancies, this is a cationic vacancy because earlier there was a cation, sodium ion here. These vacancies will be equal in number to that of strontium ions. How many strontium ions are coming? That many cationic vacancies will be there. Here you see in this figure, this site remains vacant because one strontium ion has replaced sodium. So we find here a vacancy. So introduction of cation vacancy in NaCl by substitution of Na plus by Sr2 plus, that is strontium ion. Now we will find some non-stoichiometric defects. Now first of all let us understand what is a non-stoichiometric compound. Non-stoichiometric compounds are defined as any solid chemical compound in which the number of atoms of particular elements cannot be expressed in a ratio of a small whole number. The ratio of particular element cannot be expressed in a ratio of a small whole number. In that case, we say that it is a non-stoichiometric compound. So now we will see non-stoichiometric defects. There are certain inorganic solids which contain constituent elements in non-stoichiometric ratio, and this happens due to defects in their crystal structure. So we will find that there will be two types of defects. One is metal excess defect and another is metal deficiency defect. So one by one we see. First, metal excess defect. Metal excess defect can arise due to anionic vacancies, means anion is vacant, anion is not there, so naturally metal will become more. So this will be metal excess defect. For example, we see that in alkali halide like sodium chloride, it will show this type of defects. When it happens, when crystals of sodium chloride are heated in an atmosphere of sodium vapor, what happens is that the sodium atoms are deposited on the surface of the crystal. What is getting deposited? Sodium atoms. Sodium atoms will get deposited on the surface of the crystal. Now, because sodium atom has come, its friend is chloride ion. Chloride ion will now diffuse to the surface. It will go near the sodium atoms and it will combine with sodium atoms. But see, sodium atom cannot combine with chloride ion. First of all, sodium atoms should go into ionic state. It has to form ion. How it will form ion? Sodium will lose electrons. Okay. So sodium it will form ion by loss of electron. This happens by the loss of electron by sodium atom to form sodium ions. Now sodium ions and chloride ions can combine. Now what has happened? It has lost the electron. These released electrons will diffuse into the crystal. Okay? These electrons which are released, it will diffuse inside the crystal and it will occupy anionic sites, means where earlier there was anion, where earlier there was chloride ion. Chloride has gone up, it has left its place and it has diffused to the surface. So there will be a vacancy at the anionic site. These electrons will go to that anionic site. Okay, the released electrons will diffuse into the crystal and occupy the anionic sites. Now these anionic sites which are occupied by unpaired electrons are called as F centers. They are known as F centers. These will impart yellow color to the crystals of NaCl. Okay, when F center is formed, it will impart yellow color to the crystals of NaCl. Similarly, excess of lithium will make LiCl crystals pink. Excess of potassium will make KCl crystals violet. Now, how this will come about? You see in this figure, there is electron. Earlier there was some anion here, but now there is an electron here. Okay. It is this anionic site is occupied by unpaired electron. Now why I told that it will get yellow color. Okay, because of this we get yellow color to the crystals of NaCl. This color, how it will come? It will come by the excitation of these electrons. See, when visible light falls on them, they will absorb energy, means they absorb particular wavelength that imparts color to these metal excess compounds. Next, metal excess defect due to presence of extra cations. See, metals form cations only, so whenever there are extra cations at the interstitial sites, there can be metal excess defect. For example, zinc oxide. Normally zinc oxide is white in color at room temperature. When we heat it, it will lose oxygen and it turns yellow. This is the equation. ZnO, on heating, it will lose oxygen and Zn loses electron to form Zn2 plus. So there will be excess of zinc in the crystal. There will be excess of zinc in the crystal, and now the new formula becomes Zn1 plus X O. Okay. So there are excess of Zn2 plus ions. Zn1 plus XO. So there is some excess. Actually it should be ZnO. Original formula should be ZnO, but here you see there is addition of X. Some addition. Zinc is more than oxygen. Because oxygen has left here, oxygen has gone out, it is losing oxygen. The excess Zn2 plus ions will move to the interstitial sites and the electrons to neighboring interstitial sites. Okay. The excess of Zn2 plus ions move to interstitial sites and the electrons to the neighboring interstitial sites. Next is metal deficiency defect. There are some solids which contain less amount of metal as compared to the stoichiometric proportion. Like say in crystals of FeO. In crystals of FeO, some of the Fe2 plus cations, they are missing. So if Fe2 plus is missing, there will be imbalance in the charge. So that loss of positive charge is made up by the presence of Fe3 plus ions. Means Fe3, see, 3 Fe2 plus ions will carry 6 positive charge. 2 Fe3 plus ions also carry 6 positive charge. But there is a loss of one cation, means loss of this iron. So sometimes we find that a typical example in FeO, which is mostly found with a composition of Fe 0.95O. Okay. Fe 0.950 means it should be FeO, that is Fe1O1, but Fe is less than 1. It may be Fe 0.950. So this is because some of the Fe2 plus cations are missing. So what happens? These Fe2 plus ions are replaced by Fe3 plus ions. I hope you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to the channel. Thanks for watching. Thank you.